Yeah. I have a problem with that one.
You're saying this year, folks?
Yeah, that's exactly what I'm saying. Sounds terrible.
Oh, but you posted solutions.
So you guys, can I tell you what was in my mind when apparently when I wrote this exam? The graph of this is I asked, the graph of this is a hyperbola. You stand hyperbola because things factor so nicely. Actually, it's hyperbola translated 1 unit to the left. But then reflected through the y-axis. What's something like this? Is that okay?
Yes.
And so in red, if I just draw an arbitrary line y equals mx, at least with the way I drew it, then can you identify the region for which I can't speak, sorry you guys. Can I rephrase that? Can you tell me where the region is?
Why did you
That's-
shift it to the right?
You did shift it to the right.
Oh, I did not. I shifted it to the left, then reflected over the y-axis. Because I took y equals 1. I took y equals 1 over x plus 1 and replaced the x with negative x. So you guys, in my picture, the way I drew it, somebody identify where the region is that's bounded by these two curves. Which quadrant? How about none of them? I don't think there's any bounded region. I think whatever region you look up, like this one right here, is unbounded. And so I think I can draw a red line in such a way that I get a bounded curve by positioning it where? By positioning it where?
To the left.
Steeper and steeper until I finally hit my curve at a single point. Then beyond that will give me a line, y equals mx, for which I have a bounded region. Do you see my point? For example, look at this red line right here. I think if my red line's steep enough, I will get a region that's bounded by those two curves. Do you not agree? Yes, sir.
So when you say bounded region, it has to be touching, the red line has to be touching the black line at 2 points? Or
Yes, that's what I mean. And by the way, can you appreciate I did a lousy job? I mean, if the equation is y equals mx, I meant for it to go through the origin. Sorry. I was a little sloppy. So, how the heck do I come up with the slopes for which that's going to happen? In words, no math, in words.
Take 2 points from the black line and use the slope intercept?
So I can look at the slope of that line.
Yes.
It's going to help that much, though, when I have it drawn like that. Wouldn't I want?
Would I have to do something with the estimation technique? The
No.
secant line?
All right, I got an idea. Don't look at secant lines, look at tangent lines, like this blue one. I want a yes or no answer. Does it look like that's a tangent line to my graph in black?
Yes.
Yeah, it is. I think that extreme position here with that one line in red for which I touch my curve at a single point, that's also a tangent line. But that tangent line passes through where? What interesting point? How about 0, 0? How about the origin? So if I can just create an arbitrary equation of a tangent line, I'll just look at the equation of the tangent line, force it to pass through the origin. That'll tell me what the value of x is going to be. Yes? No? Right? Let me see that again. Too many blank stares. If I create the equation of an arbitrary tangent line to the graph in black, and then force that tangent line to pass through the origin, that's going to give me the one line that hits this black curve at a single point. that'll give you the slope of that tangent line, but it'll also allow me to have the slope strictly bigger than that, that's still positive for any other line that's a secant line passing through the origin that sections off the boundary region for the curve. And if you look at the work I do, when you look at it, that's exactly what I do. Getting such negative reactions.
So is this one of the, wonderful
Thinking
evil questions that you put on the test?
I would never use the word evil.
Okay, happy questions that you
There
put
you
on the
go.
test? Or did this come from a quiz or something like that in that class that you
No,
took?
it's made up.
It's just made up? Oh, wonderful.
Yeah, I write my notes.
I was curious, could you say the part about the tangent line again? 'Cause
Yeah, just to support. I know I'm not answering the question directly. I'm kind of going to be using a roundabout way of getting here, but I'm simply saying this. X-axis, y-axis, the nifty little hyperbola. And with my blue pen, I want you to consider an arbitrary tangent line, like for example here. Do you agree that that tangent line does not pass through the origin?
Yes.
Yes.
However, this is an interesting tangent line right here. Tangent to the curve at a single point, but passes through the origin. And I think if I could find the slope of that tangent line, then I've answered the question. Because I think any positive slope value bigger than this slope value for the line in green will allow me to come up with a line that passes through my hyperbola in such a way that I section off a bounded portion of the curve. So the question now becomes this. Can you just create in blue an arbitrary equation of the tangent line to the graph of that equation? Once you do it, force x and y to be 0 for both. Force that tangent line to pass through the origin, in other words, and you can solve for m eventually. Yes?
What wording in this question makes us want to make the line pass through the origin?
No wording. It was a thinking question. That's something for you to consider. You should deduce that that's got to be the case.
So,
No, it's like worth 15.
This is a math question, isn't it?
could we just take 2 points and use the slope-intercept form and then pick the slope of that line?
Well, you certainly want to use the point slope formula
Yeah.
to generate the equation of the line, which is exactly what I did when you got in here and looked at the typing I did. I did the same thing. Oh, there it is right there. Y minus y1 equals m times x minus x1. It's just an x1 is a. Y1 is, well, the corresponding y value here when I plug in for x. Oh, well, look at that. M is just y prime evaluated a. And there's my y prime. I did exactly that. Anyway, you guys remind me in class, I'll make